Welcome to Daily Papers, where we break down the latest and most interesting academic research.
Imagine you have a really tough scientific question, something that could lead to a major breakthrough. Would you rely on the opinion of just one single expert, no matter how brilliant they are?
Probably not. You'd want to assemble a committee, right? Get a group of experts, have them all weigh in, and then combine their knowledge to find the best possible answer.
Exactly. And today's paper does precisely that, but for artificial intelligence. It's called Roundtable policy, and it's a new method for making AI much better at scientific reasoning.
We've all heard of large language models, or LLMs, like ChatGPT. They can write essays, answer questions, and even code. They're incredibly powerful, but they have a few well-known problems, especially when it comes to high-stakes work like science.
The biggest one is what researchers call hallucinations. This is a fantastic term for when an AI confidently just makes things up. It sounds completely plausible, but the information is just wrong.
It's like that student in class who is incredibly confident but hasn't actually done the reading. For a casual question, it might not matter, but in science, where facts are everything, a hallucination can be a disaster. AIs can also produce fragmented explanations or make huge logical leaps.
So if one AI might get it wrong, the natural next thought is, why not just ask a bunch of different AIs and see what they all say?
And that's the starting point for this paper. But their method is much more sophisticated than just taking a simple vote. They call it the Roundtable policy, and it's a framework designed to mimic how a real scientific committee works.
Okay, so let's break down how this AI roundtable actually functions. Who's sitting at the table?
First, you have what the paper calls the players. These are a group of different LLMs. Think of them as the committee members. You could have GPT-4, Llama, Claude, and others all in the room. You give them all the same scientific question, and each one comes up with an answer.
So you get a bunch of different perspectives, but some of those answers are bound to be better than others. How do you sort the good from the bad?
This is where it gets really clever. The next step involves an AI committee, which is made up of another group of LLMs called graders. Their only job is to evaluate all the answers that the players came up with. They read each response and give it a score for quality.
So the AIs are grading other AIs. It's like AI peer review.
Exactly. And the graders don't just give a score, they also provide a confidence level, basically how sure they are about their own grade. This process is repeated over and over again across thousands of different questions, covering everything from biology to mathematics.
And all that data has to be going somewhere.
It goes into building what the paper calls a confidence weight table. You can think of it as a detailed reputation scorecard for every player. After thousands of rounds, the system learns the unique strengths and weaknesses of each AI. It might learn that one model is an absolute genius at physics problems, but tends to be a bit fuzzy on biology, while another is the complete opposite.
So it's not just about who is smartest overall, but who is the expert for a specific type of task.
Precisely. And that reputation scorecard becomes the key to the final step. When you have a new, real question you want answered, you give it to all the players. Their answers then go to a fusion agent. This final AI acts like the committee chair. It looks at all the answers, consults the reputation scorecard, and then intelligently combines the best parts of each response into a single, final consensus answer.
It gives more weight to the AI that has a proven track record for that specific topic. That makes so much sense. So the big question is, does this AI committee actually outperform a single AI genius?
The researchers put it through its paces with two major tests. The first was like a broad scientific exam with questions from 9 different fields, including material science, geoscience, and math. They wanted to test its breadth of knowledge.
And how did it do?
The roundtable policy was a clear winner. On average, it produced answers that were 13% more accurate than even the best performing individual AI. It was particularly good at the really tough reasoning-heavy tasks, where it could piece together insights from different models.
Okay, so it's good at short answer exam questions. But what about more complex creative scientific work?
That was the second test. They asked the AIs to write a full, structured scientific research proposal, the kind that needs to be creative, logically sound, and persuasive.
A much harder task.
And again, the roundtable approach came out on top, improving the overall quality of the proposals by about 11%. The final fused proposal was better at connecting the background, the methods, and the potential impact into a coherent story. It could take a creative idea from one AI, a rigorous method from another, and combine them seamlessly.
So, what's the big takeaway here? Is it just about squeezing a bit more performance out of our AI models?
It's actually more than that. The authors argue this is about building more trustworthy and transparent AI systems. Instead of getting an answer from a mysterious black box, the roundtable policy is more like an open committee meeting. You can see each member's contribution and understand how the final consensus was reached because you have a reputation score for everyone involved.
It replaces the idea of a lone AI genius with the concept of collective intelligence. For the complex challenges we face in science, a diversity of perspectives, carefully weighed and combined, is often the most powerful tool we have.
This paper shows that the same principle might just be true for our artificial intelligence partners as well.
A great way to make AI a more reliable and accountable tool for future discoveries.
That's all for today's daily papers. Join us next time as we dive into another fascinating piece of research.